In this section, we'll continue taking questions from the 11 most repeated topics in chemistry UTME. Remember to pause, attempt before you watch the solution. Question 11. What current in amperes will deposit 2.7 grams of aluminium in 2 hours? This question is under Faraday's laws of electrolysis, and remember that I said that we have univalent monoatomic ions. We have the silver ion as an example. It will require 1 Faraday. Then the divalent monoatomic ions, example copper. Copper will require 2 Faradays, and aluminium, which is a trivalent monoatomic ion, an example, it will require 3 Faradays. Now let's focus on our question. We have aluminium here. The expression we are going to use is mass equal to relative atomic mass times the quantity of electricity all over the valency times 1 Faraday, which is 96,500. Our mass is 2.7 gram. Relative atomic mass, we have 27 gram times quantity of electricity, which we do not know, and the valency 3 times 1 Faraday, 96,500. Now look at this quantity of electricity. That is what we're going to use to find our current in amperes. Sometimes you may not be given your quantity, but you can be given your current in amperes, which is your I, and also your time. So you change your time to seconds, then multiply current by time, then you get your quantity, and then fix into the equation and solve. That is if you're not given quantity, but you're given your current and also your time. Now let's go ahead. We have 2.7 gram times 3 times 96,500. We have it as 781,650, which will be equal to 27 times Q times 1. We have 27 Q. So our Q is simply 781,650 divided by 27. We have it as 28,950. So our quantity of electricity is 28,950. Now remember that Q is current in amperes times time in seconds. So we're going to change our time to seconds. We have 2 hours. We will change it to seconds by doing 2 times 60 minutes times 60 seconds. We have 7,200 seconds. So our current I will simply be quantity of electricity divided by time in seconds. So our I is 28,950 divided by 7,200. We have 4 seconds. And that is our option D. I hope that was easy to solve. Okay, we'll go over to the next question. An example of a neutral oxide is, a neutral oxide is neither acidic nor basic. So a very good example is the carbon 2 oxide. Aluminium oxide is amphoteric. It can act as an acid. It can also act as a base. The nitrogen 4 oxide and the carbon 4 oxide are both acidic oxides. Next question. Alloys are often used in preference to pure metals because? Now this is simply because metallic properties are improved in alloys. For instance, you have an alloy, brass, which is made from copper and zinc. You see that brass will have a better property than copper and also a better property than zinc. So this is why you have to mix copper with zinc in order to have brass, which has the metallic properties improved. Okay, next question. In the graph below, the activation energy of the catalyzed reaction is, this question is under chemical reactions. Now, activation energy is the minimum amount of energy required to cause a reaction to work. And in order to reduce this activation energy and increase the rate of reactions, catalysts are used in a reaction. So this catalyzed reaction will have a lower activation energy than the uncatalyzed reaction. Now let's look at the catalyzed reaction. You have the activation energy from the center of this curve here. that is 200 kilojoules. This is for the catalyzed reaction. The activation energy will be 200 kilojoules minus, you trace down to this reactant line here. You have it as 100 kilojoules. So activation energy for the catalyzed reaction is 100 kilojoules because 200 minus 100 is 100, option C. But for the uncatalyzed, you have it from 300. This is the uncatalyzed reaction. You have it as 300 kilojoules minus, still down to this reactant line, 100. And that is 200 kilojoules. So you see that catalyst reduces the activation energy from 200 to 100 kilojoules of energy. Next question. In the reaction, we have a reaction between nitrogen and oxygen to give us an oxide of nitrogen. An increase in the total pressure will. Now you have to note that according to Le Chatelier's principle, pressure is one of the factors that affects a system in equilibrium. And there are conditions for pressure to affect this system in equilibrium. The reactants and also the products, so the species involved, must be gases. So you can say they are gaseous. And secondly, the number of moles must not be equal. That's the number of moles for the reactants must not be equal to that of the product. Now let's look at this. Let's look at the reactant species. We have nitrogen and oxygen. They have 1 mole each, and that gives you 2. Let's look at the product. The product has 2 moles. So you see that they are equal, and for this, pressure will not affect this system in equilibrium because this second condition does not hold. The number of moles must not be equal. If the reactants were like 2 and the product 3, or the product 1, then pressure will definitely affect it. But because they are equal, pressure will have no effect. I hope you enjoyed this section. Okay, now if you'd love to have more access to more UTME past questions with simplified, detailed solutions, then